this video, we will discuss about minimum time to visit a cell in a grid. You are given a m cross n matrix grid consisting of non-negative integers where grid of row comma col represents the minimum time required to be able to visit the cell row comma col, which means you can visit the cell only when the time you visit is greater than or equals to grid row comma col. You are standing in the top left cell of the matrix in the 0th second and you must move to any adjacent cell in the 4 directions up, down, left and right. Each move you make takes 1 second. Return the minimum time required in which you can visit the bottom right cell of the matrix. If you cannot visit the bottom right cell, then return -1. So what they are saying is that in the input, we are given a grid which consists of positive integers of size m cross n. In this, the value inside the grid denotes that we can enter this particular cell only when our time is greater than or equals to this value. What we need to do is, initially we are at the top left cell of the grid and we want to go to the bottom right cell of the grid. Now, whenever we are at any cell, we can either move to the top, to the left, to the right, or to the bottom. Now, when we make one move, then that requires 1 second of time. Meaning, whenever I will move from this cell to this cell, my time will be increased by 1 second, right? And I can enter a particular cell only when my time is greater than or equals to the value in that particular cell, right? So now you need to return that how much is the minimum time required for going from this particular cell to the bottom right cell, right? And if it is not possible, then we need to return -1. So first let's understand what is going to be our base condition when our answer is not going to be possible. So see, when I am at this particular cell, my time is 0 initially, right? What is my current time? It is 0. From here, I can move towards right, bottom, left or top. Left and top is not there, so I can move to these two cells. Now, if you see, for this, my time should be greater than equals to 5. Only then I can enter this particular cell. When I will move from this cell to this cell, my time will be increased by 1. So then that means for entering this particular cell, the maximum time that I can have is only 1. So then that means I cannot enter this cell because 1 is not greater than equals to 5, right? But here if you see, for this one, when I will move from here to here, my time will be increased by 1. So my time will become 1 and this one is greater than equals to this one. So then that means I can enter this cell. But let us suppose that here also we had some value which was greater than 1, 2, 3, 4, 7, 8, 10, anything, right? So in that case, from this particular cell, I won't be able to go in this cell also and in this cell also, right? So in this case, our answer is going to be -1 because we cannot move forward from the initial cell itself, right? So what you can do is that if the indexes are 0, 1, 2, 3 and then 0, 1, 2, right? So you can check that if grid of 0, 1 is greater than 1, right? And grid of 1, 0 is also greater than 1, meaning both of these values are greater than 1. In that case, we cannot move forward. So we will simply return -1, right? So this is our base case. Otherwise, our answer will always be going to be possible. So now we need to identify that what is the minimum time required, right? So see, whenever I am at a cell, I can move in 4 directions, right? Now, if there is a cell which I have already visited, I won't visit it again, right? Because I don't want to get stuck in a loop, right? So we will have to mark that what all cells we have already visited, right? Next, when I am at a cell, I can move in 4 directions or in 4 cells. So now which one should I prioritize? So if let's ignore the fact that we cannot move from 0 to 5, then in that case, which one would you prioritize? 1 or 5? Obviously the cell which is having small time, right? Because eventually we want to minimize the time. So we will give priority to the cell which is having smaller time, right? So what we will do is we will maintain a priority queue in this case and we will try to apply some kind of BFS here, right? So that priority queue, what will do is that it will take the minimum time first. The cell which is giving you the minimum time, that will be considered first, so that at the end when we reach at the bottom right cell, then we can get that what is the minimum time that was required to reach this cell, right? So that is why we are going to maintain a priority queue, or we can say a min heap, right? We will be maintaining a min heap because we want the smallest time the minimum time to be present at the top, right? So now for a particular cell, what all things you will need to push into your priority queue? Three things. So first will be the time. The time will denote that what is the time at which you entered this particular cell, right? And then you need the indexes of the row and column of that particular cell. So next will be row and next will be column. So these three things we will be pushing into our priority queue, and it will always keep a cell with the minimum time at the top, right? So we will take one of the cell, we will check whether it is equals to the target cell or not. If it is equals to the target cell, then this time denotes the minimum time required, so we can simply return this. Otherwise, we will consider its neighboring cells. Out of all these neighboring cells, whichever are not visited, that we are going to push into our priority queue with the time, and we will mark them as visited also, right? Simple. But now the point here is that how are you going to calculate this time for all the neighboring cells? That is what we need to identify, right? So let's focus upon that. So see, whenever I am at a cell, what all things I will be having? I know the current time, right? I know that what is the value present in the next cell that I am going to consider, right? So let's name it as next time, right? Let it be next time. Now I want to identify that when I will enter this next cell, then what will be my new time when I will be entering this particular cell, right? So let's denote it with new time. So this new time is what I need to identify. Current time I know with the current cell, and the next time is the next neighboring cell that I am considering, right? So now whenever I will move from my current cell to the next cell, always my time will be increased by 1, right? It is mentioned in the question that whenever we are making one move, our time will be increased by 1 second, right? So then that means whenever I am moving from the current cell to the next neighboring cell, my current time will always increase by 1, right? So instead of current time, we can consider an updated time, right? We will consider an updated time, and this updated time will be nothing but current time plus 1, right? Our updated time is going to be current time plus 1. So see, now when I am at this particular cell, what is my current time? It is 0, right? And what is my next time? It is 1. If I write it here, my current time is 0, my next time is 1, right? And since I am saying that whenever we are making one move, my time is always increasing by 1, so I will consider an updated time which will be equals to current time plus 1. So my updated time in this case will be 0 plus 1, that is 1, right? So then that means when I will be entering in this particular cell, my time is going to be 1. Is this 1 greater than or equals to the value in the next cell? Yes, it is. 1 is equals to 1. Then that means I can enter this particular cell with this updated time, right? So this next cell's value we have stored in next time, right? So if my updated time is greater than equals to next time, then in that case, with this updated time, I can enter this particular cell. So what will be my new time? My new time will become equals to the updated time, which was nothing but current time plus 1, right? So one condition that we have got here is that if my updated time is greater than or equals to the next time meaning the value in the next cell, then in that case, my new time is going to be equals to the updated time, right? Otherwise, what we are going to do? So let's see that. So in this particular case, for this particular cell, our current time will become 1, right? So here our current time is 1, right? Now from here, we can either go to this 0, to this 1 or to this 3. But this we would have already visited, so we won't visit it again. So we will go either to this cell or to this cell, right? So let us consider that we are moving to this particular cell. Now in this case, what will happen is that what is our current time is 1, and what is the value in the next cell? What is the next time? That is also 1, right? Now we are calculating updated time, which is current time plus 1. So the updated time will become equals to 2, right? So now you will again check, is the updated time, that is 2, greater than equals to next time, which is 1? Yes, it is. So my new time will become equals to 2, right? So then that means for this particular cell, my new time is going to be 2, right? Then from here, we can go to here or here. Let us consider that we are going to this particular 2. I'm just trying to identify all the scenarios so you can identify that what is going to be your new time, right? So let's suppose we are going to this particular cell 2, right? Now in this case, what will happen that the current time is 2 and the value in the next cell is 2. The next time is also 2. Now in this case, updated time will become 3. 3 is greater than equals to 2. So new time will become equals to 3, right? So the time for this cell will be 3. Now from here we can move to 8 or 5. Let us suppose that we are moving to 5. Then what will happen? So my current time is 3 and the next time is 5, right? What will be the updated time? Updated time is 4. Now you will see that my updated time is not greater than equals to next time. So now what I do? What should be my else part? So see here, the one move that we are going to do from moving from this cell to this cell, that we have already considered, right? But still there is a difference between these two. That means my time right now is 4 and I can enter the next cell only when my time is greater than equals to 5, right? So then that means I will have to waste some time, right? And in the question it is mentioned that I cannot sit idle at any point of time. In each second I have to move in any of the adjacent cell, right? So when I am at this point and I need to move to this particular cell, I want to waste some seconds so that I can enter this cell, right? And how many seconds I have to waste? So current time is 4 and the value in the next cell is 5. Then that means 5 minus 4, that is 1. 1 second has to be wasted somewhere, right? Now I cannot waste this 1 second sitting in this particular cell only. I will have to move somewhere, right? So what I can do is that I can move to this cell and then come back again. See, from this cell we had come here, right? So then that means I can move back also, right? So what I can do is I can go back to this cell and come back here, right? With that I can waste some seconds. But point to be noted here is that when I will move back, it will take 1 second, and then when I will come back again, it will take another 1 second, right? So whenever I am doing this one round trip or one operation, then it is taking 2 seconds of time. 1 second, 2 second, right? So basically I am saying that one operation is taking 2 seconds, right? So then that means when I want to waste 1 second, I will go here and I'll come back here. Then my number of seconds that will be wasted is 2, right? So what we can do is that with the help of how many seconds we want to waste, we can identify how many operations do we want to perform, right? So for wasting 1 seconds, I will have to perform one operation, right? And how can you write a formula for it? So if I do the CL of 1 divided by 2, basically the number of seconds that you want to waste divided by the number of seconds that is being used in one operation and the seal of it. So this will give you the total number of seconds that will be wasted for wasting these many number of seconds, right? So this will be what? 0.5 and the seal of 0.5 will be 1. So this will give you that, okay, for wasting 1 second, you will have to perform one operation, right? And in one operation, the number of seconds that are being used is 2. So you will also have to multiply this by 2. So this will be 2. So that means the total number of seconds wasted will be equals to 2, right? So your updated time was 4. In this updated time, you will add the total wasted time, which is 2, right? So the new time will become equals to 4 plus 2, that is 6, right? So basically here the time was 3, you moved back, time became 4, you came back, time became 5, right? And then you go here, the time became 6. Then that means when we entered this particular cell, our new time was 6, right? So what is this formula that we derived? That first we identified that how many number of operations do we need to perform, right? And how do we identify the operations? So operations will be equals to the seal of what? The number of seconds that have to be wasted divided by 2. And how are you identifying the number of seconds to be wasted? Next time minus the updated time, right? So basically what you will do is that seal of next time minus the updated time, right? This divided by 2, right? So this will give you the number of operations that need to be performed. Now, for each of the operation, the total number of seconds that will be wasted will be equals to 2 into the number of operations, right? So now, what is going to be your new time? Your new time will be equals to updated time plus the number of seconds that you have wasted, right? So plus waste. So this is what we are going to do when our updated time is greater than next time. All of this operation we need to perform. So with this, we will be able to identify that, okay, for the next cell, what is going to be my new time, right? So for this 5, we identified that the time will be 6, right? Let's identify for this 8 also. Let's suppose we are moving from this 2 to this particular cell 8. Then what will happen? So your current will be 3, right? And the next time will be 8. New time we need to identify, and the updated time will be equals to 3 plus 1, that is 4, right? Now, how many operations you need? So 8 minus 4 will give you 4. These many seconds you need to waste. For wasting these many seconds, you will have to do ceil of 4 by 2 number of operations, which will be equals to 2, right? So these are the number of operations that we need to perform. Each operation is taking 2 seconds. So 2 into 2 will be 4. 4 is the total number of seconds that are being wasted. So this 4 will be added to the updated seconds, and we will be able to get the new time, which will be 4 plus 4, that is 8, right? So if you see here, the time was 3, right? We moved back, time became 4. We came back, time became 5. Then again we did back, time became 6. Then we came back, time became 7. And from here we went to this cell, time became 8. So this is the new time that we have calculated. So this is how we are going to solve this problem. So let's quickly look at the code. So first of all, let us write down the base condition. So the base condition is that if grid of 0, 1 is greater than 1 and grid of 1, 0 is also greater than 1, then in that case return a -1. We cannot go further. Otherwise, we will try to identify our answer. So first, let's take the total number of rows and columns. So int m will be equals to grid dot size, that is equals to the number of rows, and n will be equals to grid of 0 dot size, which will be the number of columns. Next, we need our 4 directions in which we are going to traverse, right? So we will create a vector of vector, and this will be an integer. Let's name it directions. Now what all directions is it going to store? So the first direction will be to the top. So in that we will do row plus 1 and column will remain the same. Next will be down. So in that the row will be -1 and column will remain as is. Then towards the right, so in that case row will remain as is and column will be incremented by 1. And then towards the left, so row will remain as is and column will be -1. So these are the 4 directions. Next, we need a visited grid to mark the cells as visited. So we will create a vector of vector integer. Let's name it visited, and it will be of size m cross n, right? So vector int n comma, and then initially we can keep it as -1, all the values, right? So -1 will denote that this particular cell is not visited. Then we need a priority queue for storing our cells along with the time, right? And priority queue also has to be a min heap. We want minimum time at the top. So we will create a priority queue, and this is going to store 3 things. So we will create an array of type integer and the size is going to be 3, and we want it to a min heap. So vector array int comma 3 comma greater, and then let's name it pq. So this is how we are going to declare our min heap, which will store 3 values at a time, right? And here we will also have to close our vector, right? So now we will push our initial cell into the priority queue. So in PQ, what are we going to push? So for the initial cell, time is 0, row is 0, and column is also 0, right? And we will also have to mark it as visited. So in the visited vector at the index 0, 0, we will mark it with 1, that okay, this particular cell has been visited, right? Now we are going to run a loop that while our PQ is not empty, while our priority queue is not empty, take the top value. So auto. So this is going to give us 3 values. One will be the current time, next will be the row, and the next will be the column. So this will be pq dot top, and then we will pop it. So pq dot pop, right? Now we need to check whether this particular cell is our target cell or not. So if row is equals to m minus 1 and column is equals to n minus 1. So this is the target cell. So we will return our current time, right? Otherwise, we will consider our 4 directions, right? So we will iterate in our directions vector. So for auto D in directions, right? So now what are we going to do is, what will be our next row? Our next row will be row plus D of 0, and the next column will be column plus D of 1. So this will give you the indexes of next cell. Now we need to check whether these indexes are valid or not. Meaning, next row comma next call, do they lie within the range of the grid, and is this particular cell already visited or not? So we will create a function, a helper function, which will tell us that whether this particular cell is not valid, right? So we will create a function if is valid, right? And what all we need to pass? We need to pass the visited vector, we need to pass the row and column of that particular cell, right? So if this is not valid, if this is not valid, in that case we will just continue, right? We won't move forward. Otherwise, we are going to consider this particular cell. So now when you are going to consider this particular cell, you will have to identify the new time, right? So let's try to identify that. So current time we are already having here. The next time will be what? Next time will be equals to the value that you are having in the next cell. And that will be grid of next row, comma, next column, right? And then we will create a new time for calculating the new time. Let's keep it as 0 initially. And then we will also have to declare the updated time, right? As we discussed in the approach, we will take an updated time which will always be equals to the current time plus 1, right? So now we need to check that if our updated time is greater than equals to next time. If it is, then our new time will become equals to the updated time, right? Otherwise, what are we going to do? Otherwise, we are going to calculate it. So for calculating, first of all, we will try to identify the number of operations, which will be equals to the CL of next time minus the updated time divided by 2.0. So this will give you the number of operations. Then how many seconds are you going to waste? 2 into the number of operations, right? So our new time will be equals to updated time plus the number of seconds that we are wasting, right? So once we have identified the new time, we will push this particular cell in the priority queue. So PQ dot push new time, comma, next row, comma, next column, right? And we need to mark it as visited also. So visited of next row, comma, next column will be equals to 1 now, right? So here we can return a dummy -1. So now let's define this is valid function also. So what we will do is, so this is going to return us a boolean. We'll name it is valid. First, it will receive the visited vector, right? So it will be visited and we will pass it by reference. Then it will receive the row and column. So int row, comma, int column, right? Now inside this, what you can check is that row should be greater than equals to 0 and row should be less than visited dot size, right? Visited size is equal to grid size only, right? So we can use visited size here. And the column should be greater than equals to 0 and column should be less than visited of 0 dot size. Then we need to make sure that this particular cell should not have been already visited. So visited of row comma column should be equals to -1. That means we are visiting this cell for the first time, right? So let's run this code. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.